We ended the last session, we had completed the assembly of the wheel. We talked about the importance of a couple of points, and I'd like to point those out to you now. Where the head of the bolt comes through the brake, coming through the wheel and the other spacer, it is important that that head does not protrude past the height of the pill or the inside of the brake. The head of your bolt may need to be modified to ensure that that is flat across there. We also talked about the importance of the proper stack height and pressure through the center of the brake. The inside bearing race will spin freely, turning the crush tube and the other wheel bearing inside race. That is very important to ensure the proper torque through the center of this brake, and we'll now show you why. The 360 brake as it comes to you is assembled complete with the caliper, the inside pad, the rotor, the outside pad, and a pressure plate. If you notice, the pressure plate has a mating bearing surface which sits exactly and flat against the inside bearing surface of the standard 1-inch bearing. Changing that bearing size or modifying that in any way might insist that this bearing surface no longer matches that bearing, and that is a critical installation piece. And let me show you why. On the 360 brake, you will notice in this cutaway version that it is a solid piece from the outside of the pressure plate through to the center of the caliper, from the outside of the caliper through to the center of the pressure plate to the very face that we were talking about on the bearing. When installed correctly, the bearing face rides the inside bearing face of that inside 1-inch bearing. When pressure is put on the outside of the brake, it spins freely because it is spinning on the bearing axis itself. The brake itself does not spin with friction. It spins freely using the bearing. It is important that when pressure is put down on this using your top hat bushing or a wedding ring spacer, that when this is clamped between the forks by the axle, that it is compressing through the center of the brake onto that bearing face, to the other bearing face, through the crush tube, to the opposite side bearing, out the opposite side of the right-hand bearing, and through the axle spacer over to the fork. It is imperative that when all that is tightened together, the axle does not spin, the bearings and axle spacers don't spin, but the outside of the bearing is then turning. That will give you your freedom for the brake. It'll provide no drag against the brake, creating extra heat, and it also sets a critical distance. The way you know that this is correct before you connect any anti-rotation arm is to tighten up the axle onto the fork tubes, onto the brake, and you will have an equal distance all the way around the caliper to the top hat. This distance is about 35 thousandths from the factory. The 35 thousandths is not as critical as the fact that it's even all the way around. When this is properly built and the crush tubes cut correctly, with all the pressure you want to put on it, that distance will be maintained, making it a solid piece all the way through. The next important thing, and make sure it's not avoided as a critical mistake, is that when you bolt on the anti-rotation arm, if you pull this arm up or down, you will be changing the squareness of the caliper to the face of the bearing. This would become detrimental to the performance of the brake. You always mount the axle first, make sure you have the same gap all the way around, then mount your arm and tighten it up. You may want to check and see if you need a spacer between your anti-rotation arm and the tab on your fork, but that spacer needs to be the exact distance, not allowing this to cock the face of the caliper or push the face of the caliper away in either direction. That will cause a binding of the brake.